Good afternoon, guys.
Good afternoon.
Sir.
Let's wait for 2 more minutes, then we'll start the session. Okay. So see, uh, is it visible to you, the screen?
Yes, sir.
Yes,
Okay.
sir.
Yes, sir.
So last time we have seen that in order to convert a kinematic chain, okay, you have to fix any one of the links, okay, with some stationary thing like earth surface, floor, wall, etc. If you fix one link and you keep uh, giving motion to one link, accordingly the motion of other links will be controlled. Okay, so that is the definition of mechanism. Now let us start with the new topic that is called as degrees of freedom. Okay, so if you have devised a mechanism, how free it is, okay, to move, okay, that is called as degrees of freedom. Okay, and technically you can define it like this, that degrees of freedom of any mechanism is the number of input parameters, okay, or variables to completely define the position or configuration of the mechanism. So how many variables or how many parameters you need in order to completely locate the mechanism in space? Okay, for example, suppose figure A, you can see it is a 4-bar chain. Link AB you have fixed. Okay, this will not move, and other links are free to move. So now if I tell you that you are already knowing all the lengths, that length of link 1, length of link 2, you know all these dimensions. Okay, and if I ask you that you tell me the position of different links, means at one particular instant, where is link 2, where is link 3. So what you will require, you will ask me for at least one variable, and that is nothing but angle theta. So say if you are knowing the angle of link 4 with respect to link 1, okay, then you can draw the link 4 because you know the length, okay, and you can easily locate then link 3 and link 2. if you have the length of link 3, what you will do, you will take that length in compass, you will put the compass at point D, and you will draw a curve like this. Okay, let me draw it. Okay, so by taking the length of link 3 in compass, putting the compass at point D, you are drawing an arc like this, that on this arc I should get point C. Similarly, point B I have. So length of link 2 I am knowing. I will take that length in compass, put the compass at point B, okay, and I will draw another arc. So where these two arcs will intersect each other will be where your point C is. You only needed one variable, that is theta, in order to completely locate the position of different links in the space. So I will say that this 4-bar chain is having 1 degree of freedom, single degree of freedom. Okay, means it requires only one input. Okay. Second, in case of 5-bar chain, as we also discussed in the previous class, that only a single variable theta 1 will not be sufficient in order to locate all other links. Okay, I need to provide you at least two variables, theta 1 and theta 2, in order to completely locate all these 5 links. Okay, because link A1 is known, link 5 you can draw at this angle, but what about link 2? If theta 2 is not given, where will you draw it? Where is point C? No, you cannot find. Similarly, from point E, you cannot find for point D. You will draw only one arc. Okay, then for point C, you will draw the another arc. Then how you will find the link 3? No, it is not possible, right? So here degrees of freedom for 5-bar chain is 2, 2 degrees of freedom. Generally the mechanism which are having single degree of freedom, okay, are very useful in practical applications. Okay, so this is the concept of degrees of freedom, okay, which tells you about the movability of the mechanism, how much your mechanism can move and how much you have constrained it. Okay, what is the meaning of plane mechanism? Meaning of plane mechanism is that the each and every point or every link moves in a single plane. Okay, it does not leave that plane, so that is called as planar mechanism. For example, you see the point C, or you take the example of point D. So how it can move? Its path is circular with radius equal to AD, like this. So this circular path has distance in x direction as well as in y direction, means in one plane. But D is not moving in z direction. Z direction you can assume to be perpendicular to the screen. Okay, this D point will not come out. It will just oscillate or move in a plane. It will not leave that plane. So that is called as a planar mechanism. Okay, and so there are some very complicated mechanism which are called as space mechanism, where the point can move in all three directions. Okay, such mechanisms are beyond the scope of this syllabus. Then if you understood what is the meaning of degrees of freedom, okay, we will proceed further. If you feel any clarity required, you can always interrupt and ask me to explain once more. Okay.
Okay, sir.
Okay. Then let us come to the expression of for degrees of freedom. Okay, if we can express the degrees of freedom with the help of some formula. Okay, so let us discuss first what is the degrees of freedom one particular link. Okay, suppose there is one link which is link DC. This is the link in this plane. Okay, because we are studying all the planar mechanism, right? So link DC is in this plane XY. Now I ask you to locate the link CD completely. Okay, or you locate any point on the link CD, that is point P, completely. That what where is the its exact position. Okay, so to completely locate this link CD, what I need, which parameters I need to you know that you need to know. Okay, in order to completely align or completely locate the link CD. So suppose I take a point P is here. In order to describe its position in XY plane, I need X coordinate, that from the X axis at what distance it is. Okay, so that will be called as Y coordinate, which is perpendicular to the X axis. I need this distance Y. Then from the Y axis, it is at what distance? So I will locate the point P with the help of X and Y. But you know that P will be here, but you cannot completely locate the link, because even if you provide the X and Y coordinate of point P, what about the other points? So you consider this link CD like this also. Okay, so if I keep link CD like this, here C and here D, then also this condition is satisfied, that point is having the same coordinate X and Y, but orientation is different. So in order to completely define the configuration of link C, I need one more variable, that is nothing but theta. Okay, and with the help of these three variables, X, then Y, and then theta, I can completely locate one link. I can completely locate one link in one plane. Do you agree with this?
Yes, sir.
Okay. So now I can say that if a link is free to occupy any position in plane, it will have 3 degrees of freedom. Okay, means one link will have how many degrees of freedom? 3 degrees of freedom. Got it? Yes.
Yes, sir. Yes, sir.
Okay. Yes. Okay. Now next. Okay. Suppose if one link is having 3 degrees of freedom, you need three parameters to define complete the position of the link. Then suppose if you are considering a mechanism. Okay. So in mechanism there are number of links. Okay. Suppose if number of links are L, if your number of links are L, then how many degrees of freedom a mechanism will have? That is, one link is having 3 degrees of freedom. So a mechanism will have in total L number of links. So total degree of freedom कितना हो गया mechanism का? That is 3L. Correct? Yes or no?
Yes, sir. Yes.
Yes. Okay. Now next. Okay. But you consider the definition of a mechanism. What is the definition of a mechanism? That in a mechanism, one of the links is fixed. Okay. Means suppose there is this fixed link A B. Okay. So its position will never change with respect to time. Okay, the link AB is already fixed. Okay, so we don't need any parameters in order to uh, find the position of link AB at any time. We will directly say that it has been fixed on x-axis. We don't need any parameters. Okay, so if in one mechanism, if one link is fixed, so its 3 degrees of freedom are not available. Its 3 degrees of freedom are not available. So my degrees of freedom of the mechanism will reduce now. It will reduce now by a value equal to 3. Got it? So a mechanism will have degrees of freedom equal to 3L minus 3. Okay. Now you know that in any mechanism the links are not free. Links are not free. Okay, they are joined together with each other. Okay, so if you join this link with each other, will their degrees of freedom get reduced? Okay, for example, see here. Here the link DC is there. Now it is free. But what will happen? Suppose I want to make a mechanism. I have to connect two links together. So what I will do, I will join the D point, end point of link CD with end point of link AB. Okay. So D A, this point I will join here like this. So D, as you have joined the point D, okay, with respect to point A. Point A is a fixed point. Okay. Now, if I ask you that you tell me the position of link CD at any time, so you are knowing that the point D will always be with point A. Okay, we have to just define the point C, that where it is. Okay, so you will tell me that only theta is required now. Only theta is required to tell the position of link CD. Means one joint has reduced the degrees of freedom of link CD by 2. If you provide one joint, ओके, सो लिंक का जो डिग्रीज ऑफ फ्रीडम जो पहले 3 था, अब वो एक ही रह गया है. दो उसकी जो डिग्रीज ऑफ फ्रीडम थी वो रिड्यूस हो गई है. ओके, सो सपोज if a mechanism have number of joints, okay, number of joints which are having single degree of freedom. Here what I will say, the joint between link AB and link CD is having single degree of freedom. The link CD can only turn, it cannot slide in X direction or in Y direction. Okay, so whatever joint is formed between these two links is called as a joint with single degree of freedom. Okay, so if a mechanism has a number of joints in it, for example, say that number is J, I will mention it here. Say a mechanism is having J number of joints with single degree of freedom. Okay, so one joint will reduce the degrees of freedom by 2. So J joints will reduce degrees of freedom by 2J. Okay, Now your degrees of freedom is this 3L minus 3 minus 2J, where J is the number of joints. Which joints? The joints with single degree of freedom. The joints where only one kind of motion is possible between two links. For example, you consider a sliding pair, a piston which is sliding in the cylinder. So in that particular joint, okay, only sliding is possible. Only sliding is possible. There is no turning, or also there is no movement in y direction also. Only in one direction. So I will say a sliding joint is a joint with single degree of freedom. Okay. So that's why we have considered that. But sometimes we come across the joint which have double degree of freedom. Okay, means at such connection between two links, two kinds of motions are possible. For example, I give you the example now. Okay, you consider it is a surface. Okay, it is a flat surface. Now suppose there is one rolling coin. Okay, this coin is rolling over the surface like this. Okay, so what is happening here? One kind of motion is possible, that this coin is rolling or turning at point of contact. Okay, this is one kind of motion is possible. But what if the friction between coin and surface is very less? Suppose very less friction is there. So what will happen when it will roll? There are chances that this coin gets getting slided also on the surface like this. Means what will happen, that point of contact will not change, but the coin will get slipped ahead without rotating. That is called as slipping. So here turning is also happening and slipping is also happening. So we say that the joint which is formed between the coin and the surface is a joint with 2 degrees of freedom. A joint with 2 degrees of freedom, because two types of motions are possible, and we denote such kind of joint with the help of letter H. Okay, so H is called as a higher joint because it has 2 degrees of freedom, or also known as a higher pair. Okay, so say if such a joint with 2 degrees of freedom, okay, so suppose if such number of joints are there in the mechanism which are having 2 degrees of freedom, then we will reduce the degrees of freedom of mechanism by number of such joints. ओके, क्योंकि हायर जॉइंट जो होता है वो सिर्फ एक ही डिग्रीज ऑफ फ्रीडम कम करता है. ओके, उसमें 2 डिग्रीज ऑफ फ्रीडम होते ही है. ओके, so then we get this formula 3L minus 3 minus 2J minus H. Okay, to calculate the degrees of freedom. If you want to calculate the degrees of freedom of any mechanism, you can use this formula. For that you need to know how many number of links are there, how many joints with single degree of freedom are there, and how many joints with 2 degrees of freedom are there. Okay, so I will go then forward. Okay, so yes, we come to this formula. If you reduce this equation, 3L, 3 is common, L minus 1 minus 2J minus H. So we get this equation. N is equal to 3 times the difference of L minus 1, then minus 2J minus H. and this particular equation is called as Kurzbach criteria. You note it down. Okay, it is used to find degrees of freedom for a planar mechanism. You note it down, note this equation, and also in that equation you mention that what is n, what is small l, what is j. J is the number of joints with single degree of freedom. Okay, minus h. H is the number of joints with double degree of freedom. So you note down, then we will move further. Again, when you will be solving the numerical on this degrees of freedom, you will get uh, more clarity. Any doubt in this?
No, sir.
Okay. If we run out of time, you please join immediately so that we can continue. Next. Okay. So see here. So degrees of freedom of kinematic pair or joint. Okay. So how to find out it? So you have to see that how many motions are possible in that particular joint. So first is your revolute joint, or it is also called a revolute pair. Okay, or turning pair, or your rotating pair, whatever. Okay, so you know that shaft is there and one pulley is mounted, and this pulley can only rotate, or this shaft can only rotate in bearing. Okay, so such a kinematic pair or kinematic joint is having single degree of freedom. Okay, here it is mentioned. Then next is sliding pair. Sliding pair is also known as prismatic pair, right? You please note it. In prismatic pair, you can see that this rod or piston, if it is a piston, it can only slide in the hole provided. It won't happen that it will have any other kind of motion. Only one kind of motion is possible, that is sliding. Then screw pair. Okay, so sliding joint is having a single degree of freedom. Next is screw pair. Now it is very special case, because a screw, you can see that it slides, it rotates, as well as it slides. Okay, but it is given that its degrees of freedom is only one. Why so? Because its sliding depends on its rotation. Means, for example, if you rotate it by one revolution, you can exactly say that how much it has slided forward or backward. It will slide equal to its pitch screw. Okay, means you can say that theta and x has some function. Okay, its rotation theta and its linear motion x, they are related. They are not independent. Okay, and if they were independent, like the rotation has nothing to do with the sliding such motion, then we say that it has 2 degrees of freedom, as we have seen in case of a rolling wheel. So if rolling wheel का जो rotation है, and if slipping is also happening between wheel and surface, then we say that slipping has nothing to do with the rotating, revolving. Okay, they don't have any relation. It is happening because of a lack of friction. Okay, so in that case, it has double degree of freedom. But in screw pair, its rotation is strictly or its linear motion is strictly a function of rotation. Okay, so we can't say that a screw has 1 degree of freedom. So I should also add one word in the definition of degrees of freedom, that number of independent parameters. Number of independent parameters, not the dependent parameters. I think it is there in that definition. Okay, so that is about that rolling pair. So rolling pair is not shown here. Rolling pair is just example of that wheel which is rotating on the surface. So here what I mentioned, see, it is pure rolling, means sleeping is not there. That's why I mentioned. So rolling pair will also have a single degree of freedom because only turning happens there in rolling. Only thing is that point of contact changes. But if it is said that with rolling, sliding is also happening, sleeping is also happening, then you will modify it to the degrees of freedom as 2. Here I mentioned that it is pure rolling. Next, screw pair we discussed. Then cylindrical pair, it has 2 degrees of freedom. See, in this is the cylindrical pair. Just the shaft is there, which is in a hole, which is present in a circular hole. Okay, so what is happening? This shaft can rotate as well as it can slide. Okay, because collars are not provided. Okay, so and if key, it is not fitted with the help of keys between shaft and pulley, then what will happen? This shaft is free to slide in axial direction as well. It can turn about this axis. So it will have 2 degrees of freedom, cylindrical pair. Then spherical pair. Spherical pair, it has 3 degrees of freedom. Okay, so this particular sphere which is present in this spherical cavity, you can turn it about all 3 axes. Though it will not slide, it will not have a linear motion in any of the axes, but it can turn about all the axes. Okay, so if you have adjusted the mirror of your motorcycle or car, okay, you can see that you can turn that mirror in about any axis. It will allow you to do that. So that is the example of spherical joint or spherical pair. And you have seen that what is the degrees of freedom of each of these joint. Okay, then let's go to
How can we turn the spherical pair in y direction?
spherical pair in.
Y direction, up or down?
Yes, why you cannot rotate it? You can turn it. See, this sphere is present, say, in this spherical cavity. You can turn it like this also. आप उसको टर्न कर सकते हो या नहीं?
Yes.
This also, or you can also turn it about the third axis. You can turn it about any axis. Okay,
Okay,
that is
sir.
the spherical joint. It has 3 degrees of freedom because no mechanical element will become the obstruction in its rotation. Okay, as far as this cavity is available to you. Okay, unlike your turning joint or revolving joint, it will allow the rotation only in one direction. Okay, if you try to rotate in other direction, there will be obstruction to it.